Good evening, T Squared Tutories. This will be my second video that I'll be recording today before I have to go do my own homework. And this topic is manipulating square roots. This was sent by one of my anonymous friends who said they needed help with a few problems, so I'm just going to speed through the circled ones that they wanted me to help with. And also, a little disclaimer I'll give you, I have not actually done these. My last video, I wrote like a little script beforehand so I knew what I would do. This video, I have no clue what I'm doing. I'm just going to do my best, and hopefully I don't make any obvious mistakes. So with that being said, let's get to work. Alright, number 16. 3 times the square root of 405. Now when you're dealing with square roots, you want to be able to break them up into the individual pieces. So, let's look at, let's look at 405. 405 is a pretty, how did I get into orange? That's weird. 405 is a pretty big number. But what we want to do is say, what number, as I'll call it x, and sure, some people may think I'm overcomplicating it, whatever. What number of x do we take the square root of that will give us some number, which I'll call n? In this case, it will be, I believe it's 81 times 5. Yeah, 81 times 5. Basically, for that, we can let's rewrite our square root. And if you're wondering, yes, these are equal to each other. Just property you could do is if they're being multiplied, you can separate them. Now, let's look. We take the square root of 5. What is that going to be? No clue. Probably something irrational, and most likely not something you have to do. And if you do have to do this, I pray for you. 81, however, we can break into 9 and 9. So since 9 times 9 is 81, we can rewrite this as 3 times 9 times the square root of 5. Or more simply, 27 square root of 5. I'll put a little box on my answer, because why not? Same principle applies to 17, which is 2 times the square root of 36. 36, break it up to 6 times 6. 6 times 6 will get you 36. AKA, square root of 6 times square root of 6. Square roots cancel out. 2 times 6, 12. Also, apology in advance if I'm moving through these kind of fast. I don't know. If you would like me to slow down, feel free to say in the comments. I'll keep that in mind in the next video. Or if you think I didn't explain something enough, just say, hey, James, explain number 12. You absolutely sucked at it. And I'll go cry in my room for a little bit and then I'll explain it. Anyway, 18. 9 times the square root, 125. 125. We can break that down to 25. I said 25 and then 5. What a silly tutor this guy is. 25 and 5. Now, square root of 5 is something we can't really do. Square root of 25 makes more sense because it's just 5 times 5. AKA, meaning, if we break it up into 25, 5 like this will give you 5. 5 times 9, 45 times this square root of 5 that we didn't do anything with. Another box. Blam. 19. 8 times the square root of 27. 27 is 9 times 3. And I forgot to write 3. 9 can be broken down into another set of 3. So 3 times 3. So 8 times square root of 9 times the square root of 3. 8 times 3, aka 24 square root of 3. Oh no, my computer shut down. Well, give me a moment. My apologies. Now, seems as if this is where her worksheet gets a little harder. So now we have 12 times. Forgive me, my Apple Pencil does that sometimes. 12 times the square root, 1,764. Oh boy, isn't this gonna be fun? So, you have a big number like that, you want to just try and break it down as much as you can. So first, I see it's even because of the 4. I'm going to divide by 2 because I don't know the factors of 1,764 off the top of my head. So 2 doesn't go into 1. 2 does go into 17 8 times. Bring down to 6. Oh, 16 again. Another 8. Jeez, that was a atrocious 8. 0. Bring down to 4. 4 divided by 2 is 2. So we'll take a trillion example again. Break it into 882 times 2. I'm gonna rinse and repeat that until we start to see a pattern. Because this is still 882. It's still an even number. That means we could factor it more. So, repeating it, 2 goes into 8 4 times. It goes into 8 4 times again. 2 goes into 2 1 times. So, I'm going to get rid of this 882 over here, and along with this 4, so I'm going to write 441 is 4. Now if you break 4, you'll get 2 and 2. So, we can rewrite that as 12 times 2 here to get 24 times the square root, 441. Now, I can tell you right now, 441 is divisible by 3, so start with that. And you're probably going to ask, how do you know that? Here's a little trick. When you take any number, example 441, and add up the digits. So 4 plus 4 is 8, plus another 1 is 9. If the number you get when you add up all the digits is divisible by 3, then that number is divisible by 3. So we'll take 441, divide by 3, and see if we get something without a remainder. So 3 goes into 4 one times. So you get 1, carry the 4. 3 goes into 14 4 times. So you get 2. Bring down the 1. 3 goes into 21 7 times. So we get 147 times 3. Now if you add up the digits again, you get, let me rewrite this. Whoops. Add up the digits again. Get 7 plus 4, which is 11, plus 1 is 12. If you divide 12 by 3, you'll get 4, so it's divisible by 3. Or if you wanted to, you can add up these digits again to get a single digit number, which will be 3. And 3 is still divisible by 3, so our trick still works. Anyway, 3 divided by 147. No, 147 divided by 3, sorry. It doesn't go into 1 any times. It goes into 14 4 times. Bring down the 7, 9. So you get 49. Oh boy. Also, when I write this, I'm going to highlight them when I finish it, just so I know. It's a little easier for me. So now you have a 3. It was 3 3s. So that makes a 9. Times 49. 49 is a lot easier to work with, because that's just 7 times 7. Perfect. So, going back to this, we have 24 times this 9, or should I say this 3. And now I'm in green. Interesting how my pencil works. 3 3. Boop. So 24 times 3 72 times the square root of 49. And that is just 7. So get 72 times 7, 14, carry the 1, 49 as we established over here. Carry that 1, you get 50. So this whole square root is 504. And just to make sure I'm right, I'm going to look it up myself, because I'm just really unfortunate if I got called out for not remembering how to do math. According to the calculator I just looked up, 504 is in fact the correct answer. So something went right here. It's fantastic. 21, luckily they gave us easier numbers to work with. Get 3 times the square root, 900. So 900 can be rewritten as 9 times 100. These are already perfect squares, I believe is a vocabulary term. Either way, take the square root, you get 3. And 3, take the square root of 100, you get 10. And 10. So you need 3 times 3 from the 9 over here. And then 3 times 10 from this. Wait a minute. Hold on, let me just double check something. Okay, never mind. I was just double guessing myself. Ignore me. I don't know what I'm doing. Anyway. That's your answer. Final answer should be 90. Okay, moving on. Oh boy, this is gonna be another long one for me. But we do things not because they're easy. We fly to the moon, not because it is easy, but it's because it is hard. I believe that's JFK. Feel free to fact check me in the comments down below. Okay, 2,535. Okay, could definitely break this into. Pretty sure this can be divisible by 5. Let's just try that first. 2, 3, 5. Goes into 2 0 times, goes into 25. 5 times exactly. And 35 7 times. You get 507 times 5. Interesting. Very interesting. Now if you do the trick that I explained earlier, you know that this is divisible by 3. So you get 507 divided by 3. That goes into it 1 time. 2. Bring this down. 8. No, that's not 8. 6. 2. Bring down the 7. Oh, 9. Let me rewrite that because I realize that it's sloppy. That's better. Wait. Break this into 169 and 3. Once again, if you add up the digits, you get. Ooh. And you don't listen to me. 169, if you add up the digits, you'll get 16 and not 15, so that's not divisible by 3. But you know what it is divisible by? 13. Actually, I'm gonna double check myself. I feel like this is easier than I'm making it for you all. But we'll see. Oh no, I looked it up. It's irrational. I didn't think they would give you that. But yeah, it's supposed to be written in terms of what you call it? In terms of decimal points. But I don't think you have to calculate, but it's not a nice easy number like 90 or I don't know, 12 like we had earlier. Anyway, 169. What is that? That is 13 cubed. We could prove it because right now. So 3 times 3, 9. 3 times 1, 3. Add the 0. 3. This makes 3. This makes 1. 169. Now, I would highly, as a personal thing, although I don't think you would be required to do this, I would personally recommend memorizing every square up until 15. That's what a teacher, Mr. Swenson, taught me, and it has definitely helped me out on life. I can understand that's probably not something that's on the highest of your priority list, but just a food for thought, I say. Maybe memorize up to 15 squared. Anyway, avoiding yapping. This is the only perfect square out of these. So we have 13 times 7. Where do we get the 7? Over here. 13 times 7. 21. 91. Oops, I should just leave it there for now. So we have 91 times square root of 15, I think. Hold on. Today's lesson on Can I Do Basic Math? Yeah, okay, so it's just times the square root of 15. Jeez. Really, who let this guy tutor? He needs to get his license revoked. But anyway, this is our final answer because there's no more simplification that we can do. Also, the 15 came from multiplying this and this by each other, just in case I didn't make that clear. And just when I thought that I would be able to do easy problems again, your worksheet gave me more complicated problems. Thanks, buddy. Actually, as much as I'd love to say their name, they asked me specifically not to, but you know who you are. And when I see you at school tomorrow, I'll be very, very disappointed. Anyway, 12, 15. If we add up those digits, we get 5, 6, 8, 9. So it's a good idea to start with 3. So 3, 4, 0, 5. 405. Do you know what that gets us? You guessed it, another 3. So if we divide 405 by 3, you'll get 10 something. I know, it's on the tip of my tongue. 105. Oh my. Wait, no, it's not 105. Yikes, this guy sucks. Anyway, 135. 135 times 9. So that will give us 3 and 3. Give that a little highlight too. So it gives us 33 as the square root of 135. Pretty sure this isn't going to be rational, but oh well, such is life, I suppose. So 135 is also divisible by 3, using the trick. So we'll try one more time. 1, that's not a 1. 135. 3 goes into this 0 times, goes into this 12 times. No, 4 times, and then to this 5 times. So you get 45. 45 is also divisible by 3. So we can make that 15 and 3. Or should I say 15 and 9. I'm not going to highlight. I am going to highlight that again, but I'm not going to redo it because we just did it. So 33 times 3 is 99, times the square root of 15, which as you can see earlier, we don't know. Or, we do know, but it's beyond the scope of this class, respectfully. 24. A little break from the suffering. I'm a fan of it. 2 times the square root of 200. 200 can be broken down into 2 and 100. As I explained earlier, up here, actually, 100 is just 10. I did it as 10. 10. Oop. Multiply that by our 2 over here. We'll get 20 times the square root of 2. Put a little box on. Alright. That's one of many things that I was told to do. Oh, actually, I don't have many left. Okay, so this is for our next page. The goal of this one is to multiply square roots. So number 12 on this page, sorry for the unorthodox naming convention, square root of 5 times negative square root of 5. No, negative 5 times the square root of 5. And what we can do here is basically, let me rewrite the 5s, and I can show you some. 5, the 1/2 power, let's just ignore this 5 for now, times square root of 5. It can also be written as 5 to the 1/2 power. Now, when you have same bases, aka 5 times 5, you can add them. Now, 1/2 plus 1/2, that's just 1. So, when we multiply, the square root would just go away. We'll just have negative 5 times 5. That's just 25. Okay. Now we have a distributing problem. 15. Square root of 10, parentheses, square root of 10, plus 2, close parentheses. Alright. First, we want to distribute this this square root of 10, this square root of 10. Since they're the same thing, we're going to cancel out. Just get 10. Do it times here. 2 times. You'll get 2 times the square root of 10. It's no simplification. You can... Yikes, this pen is weird. Anyway, since there's no simplification you could do here, it's just 10 plus 2 times the square root of 10. Speaking of the pen, it didn't wait for a while. Anyway, 16. Square root of 5 times the square root of 5 plus 3. Do the same thing. Multiply these square roots, and you'll get 5. Multiply the square root times this number, you'll get plus 3 times the square root of 5. There's no simplification we could do there, so just leave it as is. Sounds good to me. Feel like we should do that a lot more in math. 17 is trying to trick you, but don't worry. It's the same thing we did for the last 2 problems. So square root of 5 times parentheses 5 plus square root of 5. Multiply this, you'll get 5 square root of 5. Which can't be simplified. Multiply these, you'll just get 5. And if you want to be really fancy with it, you can factor out of 5, technically speaking. It'd be 5 times the square root of 5 plus 1. But I don't know if you have to do that or not, so one of these two is your answer, depending on your teacher, I suppose. I'm just going to leave it as this, because I already did it. Alright. Whew. 22 is a tough one, because all the other ones, we had same bases, they just canceled out. We can move on with our day. Easy peasy, lemon squeezy. This one, no, we don't get to do that, sadly. So we have 3 times the square root of 6, parentheses, square root of 10, minus square root of 3. This is where we do something similar. Now, since we have 2 square roots multiplied by each other, we just multiply them like nothing happened. So you have 3 times the square root of 60 minus 3 square root of 18. I'm going to look at each of these trees individually. So 60, what are the factors of 60? 4 and... How about 4 and 15? Because we established earlier that 15 can't be simplified anymore. And 4 can be just written as 2 times 2. So, give it a fancy little highlight. And multiply, we'll get 6 times the square root of 15 minus, and now that's what we get to do a tree again, for 18. And that was odd. Anyway, 18 can be written as 9, 2, or 3 squared. Thus our tree is going to involve a 3. And now I'm a poet instead of a math teacher. Isn't that fantastic? Anyway, this simplifies to 9 times the square root of 2, and we are done for this problem. 23 and 24 are both somewhat similar in these aspects. So let me start with 23. How many pages am I at? 2. Okay, that's not too bad. 23. Negative 4, square root of 5, parentheses, 4 minus 3, square root of 10, close parentheses. Multiply these by each other, you'll get a negative 16, square root of 5. That's nice and simple. When you're multiplying these, it's going to be a little bit challenging. Just remember, multiply each one by itself. So what do I mean by that? Let's look at the negative 4 and negative 3. Multiply those by each other. Get 12. Look at the negative 5. Look at the square root of 5, the square root of 10 over here. Look at the square root of 50. I'm going to just flip these around because I personally prefer the negative to be after the positive. And then I'll re-look at this square root. Flipping around. That's not positive. Alright. Square root of 50 is just 25. Square root of 25 times 2. Square root of 25 is 5. So you'll get 12 times 5, just 60, times the square root of 2, minus 16 times the square root of 5. Alright. Last one for this page, but as you could probably guess, not the last one for all of them. Square root of 5, parentheses, negative 4, square root of 6, plus square root of 10. You know, I might actually lose my voice doing these. That would suck. Anyway, multiply by this one first. Negative 4, square root of 30, and multiply by this one second. Oops. Which is plus 50. I'll rewrite it again. I'm not going to explain it because we just did. This is 5 times the square root of 2. Just trust me. And, I don't think there's anything we can do with 30. Yeah, there's nothing we can do with 30 that I can think of. Maybe I'm just overlooking something simple again, and you can all laugh at me. Feel free, I don't mind. Pretty sure we just have to leave 30 as it is. I'll get something like this. And that will complete us for multiplication. Now we're in the home stretch. Just gotta get division of square roots done, and I can eat. Now that sounds good to me. Alright, so once again, pardon the naming convention, or numbering convention, I should say. Get 2 times the square root of 3 over 4 times the square root of 27. 27 could be written as the square root. I'm going to rewrite this as 4 times the square root. Almost forgot my little division sign there. Square root of 3, square root of 9. So these cancel out because they're multiplied. And this is just 3. So we get 4 times 3, which is 2 12s, 4, 1 6. 9. Oh, this cancels out off the bat, which is perfect for me. But anyway, let me explain it. So this is our problem. 2 divided by 2 is 1, so we can ignore that. Gives you the square root of 3 over the square root of 12. It could be rewritten as square root of 3 over GZM. If I ever monetize any of these videos, my funds will immediately be going into getting a different tip for my Apple Pencil. Anyway, this is square root of 3 times the square root of 4. This cancels out, and you get 1 over the square root of 4. And we're done. Just kidding, we're not done. Now, this really just depends on what level you're at. Usually, as you get into higher level math, they don't make you do this. But when you're at the stage of learning this geometry, algebra, around this area, they're gonna make you want to simplify. So I'm gonna go over this maybe once or twice, and afterwards I'm not going to, because 1, as I said earlier, viewer exercise to do. 2, I'm lazy. So basically, in order to simplify this, we need to get the radical or square root out of the bottom. To do this, we just simply multiply square root of 4 times the square root of 4, because these are both equal to each other. Now, square root of 4 times the square root of 4 is just 4 on the denominator. And then 1 times the square root of 4 is just the square root of 4, which happens to be 2. And then we can simplify this into 1/2. Also, I changed my mind. I think I'm gonna simplify it for all of them, just for personal practice, just for the fun of the game. Anyway, 4 times the square root of 6 over 4 times the square root of 27. 4's cancel out. I'm gonna skip a step here. 6 can be written as square root of 3 over 2. This could be rewritten as square root of 3 and square root of 9. I'm gonna skip more steps. Square root of 2, that's irrational. This proof for it, I'm not doing it. But you'll get the square root of 2 with square root of 9, which is just 3. No simplification needed for that one. 11. 3 times the square root of 20 over 4 times the square root of 16. We can take a 4 out of both of our radicals, so we can get 3 times the square root of 4, square root of 5, over 4 times the square root of 4, times the square root of 4. Boop. That's gone. Get 3 times the square root of 5, or 4 times the square root of 4, aka 2. So 4 times 2 is just 8, and we are done. For this one, at least. Trust me, the day's never finished. 12. 3 times the square root of 20 again. This time, it's over 3 times the square root of 36. These 3's cancel out. And if you would like, we could just, instead of writing it as the square root of 4 times the square root of 5 as we did over here, we can rewrite it as just 2 times the square root of 5, because that's what the square root of 4 is equal to. Over here, I'll have the square root 36, which is just 6. And we could simplify it to be 1/3. 1/3 square root of 5. Or as I'm sure that they'll prefer for you to write it as, square root of 5 over 3. Boom. Alright, last page. Who's ready to eat dinner? I know I am. Anyway, square root of 25 over the square root of 15. This is just square root of 25 is 5 times over the square root of 15, which cannot be simplified. So we just multiply it, square root of 15 over square root of 15. That'll give you 5 times the square root of 15. That looks like 8, my apologies, over 15. This cancels out to be 1/3. Then you get square root of 15. 3. Boom. A nice little box to it. 14 is the square root of 5, the square root of 15. This can be rewritten square root of 5 over the square root of 5, 3. This cancels, so you get 1 over the square root of 3. Multiply the numerator and denominator. As you can see, get the square root of 3 over 3. Cool. Ooh. How do I do this one? Never mind, I got it. 15 is the square root of 10. The square root of 6. Can take out a 2 from both. These 2's will cancel out. The square root of 5 times over the square root of 3 by the square root of 3, because they don't want radicals in the denominator. You'll get square root of 15 over 3. Again. Hey, look, it's popped up again. Hello. Mr. Murphy's wearing off on me. 16. Square root of 15. Square root of 6. Equals square root of 5 times the square root of 3 over the square root of 2 times the square root of 3. That'll cancel out. The square root of 5, square root of 2. Multiply and multiply. You'll get square root of 10 over 2. Oh, whoops. Accidentally turned off the problem sheet again. Square root of 8 over square root of 6 is equal to, we can take out a 2 again, as we did for 15, I think. Yeah, 15. Root of 2, square root 4, square root of 2, square root of 3. That cancels out. Square root of 4 is just 2. So 2 over the square root of 3. Simplify. We get 2 times the square root of 3 over 3. That can't be simplified any further. Done. 18. Square root of 6 over square root of 15. Square root of 3 times the square root of 2. Square root of 3 times the square root of 5. Cancel out. You get 2 things that can't really be simplified. So we're going to multiply the square root of 5 over the square root of 5. You're going to get the square root of 10 over 5. Only 2 more problems to go, guys. We got this. 19. It saved me a step, which I'm going to be grateful for a while. You get 3 times the square root of 3, square root of 5. It's kind of similar to the stuff we've been doing here. You get what I'm doing, saying. All we got to do is multiply by the denominator. Both the top and the bottom. And that will give you the square root of 15 because the 3 stays the same, over 5. And we can't simplify that, so we can just leave it. Now for our last problem, 3 times the square root of 3, and no, I'm not writing the same problem, over 5 times the square root of 2. This one's a little harder because it's not just a square root, but I believe in us. I believe we can do this. Something about the power of friendship. Anyway, multiply by the denominator on the top and bottom, and we'll get 5 times 5 here, which is 25, 2 times 2, which is square root of 4, aka 25 times 2. Up here, you'll get 3 times 5, which is 15. Square root of 3 times the square root of 2, which is square root of 6. Simplify that to be 15 square root of 6, or 50. And we could divide both of these by 5, so 15 divided by 5 is 3 times the square root of 6. 50 divided by 5 is 10. This is our final answer. Now, I like to explain some things. Like, for example, if you are a parent who is watching this for the first time, I'd like to apologize. I will not be treating your child like this. This is merely because this is one of my friends, and I thought they were going to give me a light workload. And they most definitely did not give me a light workload of problems to do. Right. Which, considering the fact this is only like half of their homework, probably speaks as a statement to our society and how much homework we give kids. Probably lower that, but I'm not your philosophy teacher, so I'll shut up now. Thank you for watching. Have a nice day, everyone.